Good evening, students. Today's topic is capacitance or capacity. That we can say electrical capacitance or electrical capacity of a body. Suppose you have an object with you and you are adding some charge to it. You are charging it. So to what extent that object will hold the charge, that is called your capacitance or capacity. That's why we have written here, capacitance is a measure of the ability of a conductor to hold charge. Let me put this into a simple word. In simple term, capacity refers to, like suppose you have an object, you are adding charge on it. I can say its capacity will be infinite until I have to define it by proper framing. What is that? Suppose let's say that it's a conductor, I am adding charge to it. So if I add charge on it, so if the amount of charge is increasing, the electric field produced by this object will gradually increase. It will produce a field, no, as it is a charged body, so it will produce its electric field. So if I will increase the amount of charge, the surrounding field will gradually increase. There is a certain limit up to which the medium in which the object is kept or in which the body is kept will tolerate that field. At certain extent of time, the insulation of that medium it breaks. However the material may be. Clear? Like in one simple example, you can take, let's say, air. The insulation, we know air is an insulator, but its insulation will break if the electric field, strength of the electric field will be 3 million electron volt, then its insulation will break. Means during that point of time, air becomes conducting. Example, your lightning. Lightning, what? There are a stream of charge particle or current that flows through air, because during that point of time air becomes conducting. So to air becomes conducting, for that we need the value of the electric field should be greater than 3 into 10 to the power 6 volt. Clear? That much voltage we need. So it means we can say, without, if suppose I am adding the charge and it will, the conductor will produce an electric field of the order of that magnitude. So there what will happen? The insulation of the air will break and the charge will leak out. Clear? So whatever charge I will put on the conductor, that will leak out to the air. Got? So it means I will add charge, that will flow. So means whatever charge I will give, I can say it is being kept by the conductor. So means in simple term, capacity is useless. So that's why while dealing with the capacitance, we need to be careful here. See, this is a simple mathematical proportionality here. What is that? If you add more charge, the potential of the object will increase, definitely, because potential is directly proportional to your charge and vice versa. So that's why we have written here Q is proportional to V. Q is equal to one constant proportionality into V. And this constant proportionality means Q is equal to CV, and C is a constant proportionality called capacitance of that body or the object. So clear? So it means C is equal to Q by V from this expression. So C is equal to Q by V. The interesting part here, if you increase the value of Q, V will increase, but the ratio remains constant. Clear? So it means for a conductor, its value is remaining same. So basically, it means if I increase the value of Q, the value of V is increasing. Got? So in terms of capacity, we can explain. Suppose you need to increase the potential by an amount of 1 unity. Means you suppose you are adding some charge, it acquires some potential. Let's say 10 volt. Clear? you are adding, you have given some charge, let's say at a particular point of time its potential becomes 10 volt. So to define our capacitance, what you need to do, the potential will increase by unit amount. Means earlier it is 10 volt, now you have to increase it to 11 volt. Means what? You need to add some extra charge on it. Clear? So whatever extra charge you are adding to increase the potential of this conductor from 10 to 11 volt, that is called the capacitance of the object. Clear? So capacitance, this is a literal meaning. The meaning of the definition what I have said now, it is the appropriate one. We have framed it properly. It means to raise the potential of a conducting body or an object by unit amount, whatever charge we are giving, whatever extra charge we are giving, that is called the capacity of an object or the capacitance of a conductor. Clear? So now we can find the unit of the capacitance. Unit from this expression, C is equal to Q by V. So for charge it is coulomb and for potential it is volt. So unit is coulomb or volt. And remember, 1 coulomb per 1 volt, it is called 1 farad. 1 farad is the unit of, means farad is the unit of your SI unit of your capacitance. Now you can find the dimension. Dimension C is equal, from this expression C is equal to Q by V. C is equal to Q by V. Instead of V we can write W by Q. W by Q means Wattman per unit charge from that formula. So Q by W by Q means Q will go up. So Q square by W. Q, the dimension of Q is 80. So Q square means A square T square by W. W is M1 L2 T minus 2. So if you simplify, the dimension of capacitance will come out M minus 1 L minus 2 T4 A2. Clear? Now, see, as just now we have said, C is independent of Q and V because with the increase in Q, V increases, so C remains fixed. But still, it depends on certain parameters. On which parameters it depends? It depends on the shape and size of the object. That object which is storing the charge on the shape and size of that object matters. So shape and size of the conductor which is storing the charge, and the medium in which the conductor is kept. So this medium may be in air, maybe in some water, in some other medium. So the surrounding medium in which this material is kept, the body is kept. So in that medium also capacitance depends. Also presence of other conductors or other body also matters a lot for the capacitance of the object, because they also influence its charge holding capacities. Clear? So this is the most important part here. Now comes, let us calculate the capacitance of an isolated spherical object. A spherical body is there, or you can say a spherical conductor is there. So for that spherical conductor, let us find out its capacity. So general formula for capacity is C is equal to Q by V. So what I have done here, I took a sphere whose radius is R and I have given a charge Q to it. Let's say it is a conducting sphere. So for a conducting sphere, whatever charge I will give, it resides on its surface. Clear? So we know the formula for capacity, C is equal to Q by V, and on the surface, the value of the potential for a conducting sphere is given by 1 by 4 pi epsilon Q by R. So from the shell theorem, we can find the value of potential, because here a shell theorem is suggesting if a charge is distributed over a conductor and you are looking at outside world, outside the sphere, this entire charge sphere behaves like a point charge. Means point charge of plus Q amount, and that point charge is supposed to be placed at the center. Clear? So if the entire amount of charge would have been placed at the center, then the potential at a distance r from it would be given by the formula 1 by 4 pi epsilon Q by R, which is the same for this conducting sphere. Got it? So now you got V from the same theorem, we can apply. So C is equal to Q by V if you put it here. So Q by 1 by 4 pi epsilon Q by R, Q got cancelled. So C is equal to 4 pi epsilon naught R. That means Here we took this conductor is placed in vacuum or air medium. So in that case C is equal to 4 pi epsilon naught R. Clear? So this is actually vacuum. Air and vacuum, they are almost nearly the same permittivity. That's why I say C is equal to 4 pi epsilon R in case of air medium or your vacuum. So means here you can clearly see C is directly proportional to R. Capacitance of a spherical body is directly proportional to the radius of the body. So if the medium is changed, means in any other medium where the permittivity is epsilon, in that medium the object is kept. So your capacitance will become C is equal to 4 pi epsilon R. So in this case, now if you plot a graph between C and R, you are going to get C is directly proportional to R. With the increase in R, the value of C is increasing. So the graph will be like this, and if you find out the slope of this graph, your tan theta will give you the slope, which is nothing but 4 pi epsilon R. Because if you take C to be Y, R to be X, Y is equal to mx form, which will be a straight line which is passing through the origin. So tan theta is 4 pi epsilon, not epsilon here in this case. Students, basing on the idea, so let us put a question to find out some interesting answers here. Like I have given two questions. Find the radius of a spherical conductor whose capacity is 1 farad. And second question is find out the capacity of earth or earth-like and conducting sphere. So first question, find the radius of a spherical conductor whose capacity is 1 farad. So we know for a spherical object, for a spherical body, isolated spherical body, the capacity formula C is equal to 4 pi epsilon naught into R. So from here, R is equal to how much? C by 4 pi epsilon naught. So what I have written here? So here means 1 by 4 pi epsilon naught into C. The value of C is given 1 farad. 1 farad. And we know the value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9 Newton meter square per Coulomb square. Now you put the value here. For 1 by 4 pi epsilon naught, the value is 9 into 10 to the power 9, and for the capacity it is 1 farad. So I put the unit over here. If you solve this unit, you are going to get it is meter because it is R. For radius, unit should be in meter. SI unit is meter. So if you solve, you are getting R is equal to 9 into 10 to the power 9 meter. Means it's a very big sphere whose radius is much more than that, means much more than that of your Earth. Earth order of magnitude is 10 to the power 6, but here it is 10 to the power 9, which is almost more than 1000 times bigger than that of your Earth. So if the capacitance of an object is to be 1 farad, isolated object is to be 1 farad, then its radius is to be R 9 into 10 to the power 9 meter. It's very big. Now come to the second question, capacity of Earth. We know Earth is a sphere. So the formula for capacitance of a sphere is C is equal to 4 pi epsilon naught R. Now put the value of 4 pi epsilon naught and the radius of Earth. Radius of Earth is 6.4 into 10 to the power minus 6 meter. So I put it here. 4 pi epsilon naught is what? 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So 4 pi epsilon naught is 1 by 9 into 10 to the power 9. So I put it here. Now this expression you see 6.4 by 9 into 10 to the power 6. You take it up. So it will be 10 to the power minus 9. So if you add, it will be 10 to the power minus 3. If you solve this, you are going to get 0.711 into this is 10 to the power minus 3. And as it is a capacitance and SI unit is farad, so it is F. I kept it here. Now, if you solve it, I can write 711 into 10 to the power minus 3. Here another minus 10 to the power minus 3. If you add it up, so your answer will be 711 into 10 to the power minus 6 farad. 10 to the power minus 6 is your micro. Means capacity is equal to 711 microfarad. So earth-like sphere, its capacity would be 700 microfarad.